Good afternoon, folks. So hopefully you had a good restful break. So we're coming back into systems. Now, the first thing we're going to talk about is talking about solving linear and quadratic systems. So when we talk about a system, first of all, understand that it's essentially we have two or more equations. Okay, that's kind of going to be a big part to this. Now, we're only going to really deal with two right now. Later on, we'll deal with three. Okay. And when we solve systems, what we're essentially looking for are all possible intersection points. Okay. That's what to solve means. We're going to solve for all possible intersection points. Okay. And the reason why we do that is because the points that we find will satisfy both equations. Okay. And there's two ways we're going to do this. Okay. One's going to be kind of a pretty straightforward, simple way that if you learn how to use an intersection function in the calculator, it'll be pretty straightforward. The other way is to do it algebraically, and that's when we start using the quadratic formula again. And if you don't remember what the quadratic formula is, it's going to be, I'll write it down here in a second. But I do want to kind of tell you what you're looking for before we get into this. One, it's possible to have no solutions, okay? And it basically means that you don't have any intersection points whatsoever, okay? It's possible that you have one solution because you have a line that is tangent to the actual curve, okay? And it's possible that you have two intersection points because, or two solutions because you have two intersection points of the graph. Now, the reason why we do it graphically and algebraically is because sometimes, and I'll show you an example of this in a second, where you can't really tell if it is or isn't. And if you do it graphically, it looks like it is, but when you do it algebraically, it actually doesn't work, okay? So system one that I'm looking at here, hopefully what you notice right away is that there are 2 points where the graph intersects, which is going to be here, looks like, and here. Okay, those 2 points are going to be my solution points to this particular system. And if I had the equations, I could get you the exact numbers. Okay, so system one has 2 solutions. Okay, based on this particular graph right here, this particular piece. The solution points themselves are going to be coordinates, okay, of the thing. So now if I look at this, I'm going to, this is going to be an approximation because I don't have the actual equation to do this, but it looks like it's roughly about negative, maybe about negative 4.3. And what is that? Negative 1.3-ish on the first coordinate, which is this one right here. This would be, I'm going to label this one A so you know this one's A. Okay. The second one looks like it's going to be approximately negative 0.75. And what is that? It looks like 2.5 maybe. And if I had the actual equations, I could figure these out precisely what it is. But since I don't, I'm just kind of doing an approximation at this point. And the reason why I know this is about negative 4.3, negative 4.4 is because this is the halfway mark, which is 4.5. So on the x, so your solutions have to have your x and your y component to them every time you do these. And then the y is going to be roughly, that's negative 1, negative 1.5. It's about negative 1.3, negative 1.4 also. Either one would have been fine. And then b, same thing. 0.5, so halfway to negative 1 is about negative 0.75. And then up on the y, it looks like it's about, oh, sorry, it's not 2.5. It looks like it's about 2.25. Let me rewrite that. Yeah. 2.25, okay. So when we do points of intersection, we're looking for the coordinates of the intersection points. Okay. And again, this is 2.5 right here, about 2.25. Okay. So it's an approximation based on that. If I look at my next system, so that's 2 solutions here. Now you really can't tell, and this was kind of just the way it prints out, but your actual line that you're looking at is right down here. Oh, that's bad. Let me draw this again. Kind of like this. Okay. And then this is the curve right here that you're looking at. Let me highlight that in green so you can kind of see what I'm doing here. Kind of like this. Okay. This is where having the equations really helps, because there are times when if you graph it, it looks like this line intersects this particular graph here. At that point, whatever that point is, which I'll do in a second, right there. But when you do it algebraically, it actually doesn't. There's actually no solution. That's why algebraic part is kind of important when it comes to these, because of those kinds of reasons. But system 2, just by looking at this, is we're going to say it's going to have one solution. Okay. And because this line is what we call a tangent, and essentially means when a line is tangent to a curve, there's only one point of intersection that actually occurs. And in this point, the solution looks like it's going to be -3 on the x and -3 on the y also. Okay. So this is the point I'm looking at. I'll just label this point A so you can kind of tell. Okay. And then you have system 3. And again, I said there are 3 possibilities. It looks like this. Now, what you notice about this right off the bat is the fact that this line here, I'm going to highlight this again in a little blue, with this curve right here, and again, I'll highlight this green so you can kind of see, does not intersect this curve anywhere. Now, and you can kind of look at this and say, well, maybe because the line goes off, it'll intersect somewhere else. It really won't, because the graph keeps going up this direction. This is the lowest possible point it's ever going to see. This line keeps going in this direction here. And if you were to continue to draw this out, this one keeps going up. This one keeps going way out here. So this right here, just by looking at the graph itself, is what we call a no solution. So no points of intersection. Okay. And this is what we call no solution. So those are your 3 possibilities. Okay. So we're going to look at example 1 right here. Okay. And then I'm going to show you how to do this algebraically, which is kind of the helpful part to this when it's all said and done. So the first thing I'm going to look at is, okay, I have 2 systems here, and I want to find the solution points. Okay. So by looking at the first one right here on the left side, I can see that there's a point. It looks like it's about right here. And the other one looks like it's about right here. And again, when I say about, I'm approximating these things, because without the equations, I can't really give the exact. Now, those points could be the exact. But it looks like the first point here is going to be at -3, -8. That's what it looks like. This will be point A. And then the second point of intersection here looks like it'll be 2, 7. Okay. And that's what you're looking for. It's just those 2 points of intersections. That's it. Okay. Look at the second one. And again, if I look at this, I can pretty much kind of say, well, it looks tangent. It may not be tangent. It's really hard to tell on the graph. I know what it is because I put the graph in here, and I will tell you that this point is actually tangent. And it's actually tangent at this point right here. Okay. But again, this is a good example of why you would need to have the equations to do this, to ensure what you have. Now, I'll talk about a number called discriminant again. But this point is tangent here. This is a tangent line. Okay. It has one solution at 2, -3. That's the only point that I have. Okay. We'll call this point A. We'll call this point A. Okay. So when you're looking for solutions or solving systems, that essentially is all you're looking for. Is just where are the 2 graphs crossing to each other. Okay. So now I'm going to show this to you algebraically and then verify graphically how it works. Okay. So to determine my points of intersection, first thing is that, and I'm going to kind of refer to this. It says set the 2 equations equal to each other. Then I'm going to put them into standard form. Now, if you don't remember what standard form is, that's your ax squared plus bx plus c. I'm going to check my discriminant to see how many I need, and then I'm going to solve. And when I solve, I'm going to use my quadratic formula again. Okay. So I'm going to set the equations equal to each other first. So I got -2x squared, and just so that you know, I like to put the quadratic on the left-hand side. because I'm just used to doing it that way. You don't have to, but it makes things a little easier. Okay, so that's step one. Step two is to put into standard form. So that means I'm going to subtract minus 4x here, minus 4x here, minus 7 here, minus 7 here. So that it's going to give me a negative 2x squared plus 6x minus 4, and that's set equal to 0. That would be step two. Okay. Now I'm going to use my quadratic formula. And again, this is going to be your A, your B, and your C. So if I do this, it's going to become, well, let me write the quadratic formula real fast for you so you can kind of see it. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay. So negative 6 plus or minus the square root of 6 squared minus 4 times negative 2 times negative 4 all over 2 times negative 2. And again, I'm going to do my discriminant number next. And if you don't know what discriminant number is, it's going to be this piece right in there. And I'm going to do that to ensure what I'm looking at here. So 6 squared minus 4 times negative 2 times negative 4 looks like it's going to be 4. So this is good. So you end up with a negative 6 plus or minus the square root of 4 all over negative 4, which becomes negative 6 plus or minus 2 all over negative 4, and that's going to give me two different answers. Okay. So again, I'll use my alpha bar here. So I got negative 6 plus 2 all over negative 4. So that's going to be 1. So my first answer looks like it's 1. Okay. And then my second answer looks like it's going to be at 2. Well, that's good. 2. Okay. So it's going to be at, and here's kind of the way this works so that you know. It'll be at 1 something and 2 something. Okay. And the way I can get the second point to do these, so this will be step 3. Okay. Is to take either one of these equations. I'm going to always use a linear one to make this easier. And I'm going to essentially go back and do, okay, 4 times 1 plus 7 is equal to something. This is step 4. 4 times 2 plus 7 is equal to something. And those somethings are they're going to be the y value that I need. So 4 times 1 plus 7 will be 11. 4 times 2 plus 7 will be 15. Okay. So my solution points will be 111 and 215. And that's what you're looking for. Algebraically, that's it. Graphically, I take these and I say, okay, if I do on this first one, I do a negative 2x squared plus a 10x plus a 3. And on the second one, I'm going to do 4x plus 7. And I hit graph. This is what I see. And this is why graphically is good and it's bad. One, if you know how to use a calculator to see the rest of this, it'll help. So I'm going to change my windows. I'm going to change this to 20 because I know I need to set at least 15 on my y. There's the graph. There's that. Okay. So when I go in here, I say, okay, intersect. The first one is at 111. Okay. And then I do second trace 5 again for my intersect. This time I'm going to move it up here. The other one looks like it's at 215. So again, graphically, if I looked at this, I said, well, it looks like it's tangent, but reality is it's not tangent. Okay. So, and I realized I didn't put enough spaces on this, but not a big deal. So the first one's at 111, which is about right here. Second one's at 215, which is somewhere up here. And I'm not going to do this perfectly. I'm just going to graph this real fast. And if you want to figure out how to graph it, I just get your points off the table. But there's a line that looks something like this, kind of comes like this. And again, I'm not going to, and then the other one looks like it does something like this. And again, this is not perfect. Oops. This is not going to be perfect. I already know it's not going to be perfect. It's going to look something like this. Okay. But the thing is that there you have a point up here and a point here. This is 111 and this is 215. Okay. So it looks like it's tangent based on this right here. Reality is I have 2 points because my discriminant was 4. And when you have a discriminant of positive value, you have 2 possible answers. Okay. So here's the next one. Again, I'll let you try it first before I come back. I'll do it and I'll kind of show you what it looks like graphically, and then we'll go from that point on. So try it. All right, here's what I got. And again, graphically, I verified it just so you can kind of see. This is what it looks like when you graph it. And again, without knowing, it looks tangent again, just like the first one did. But there could be 2 possibilities. In this case, though, when you work it out algebraically, and this is why algebraically works really well, when I do my discriminant value, I get 0, which means I'm only going to have 1 answer. And that means that this line is actually tangent to this curve. And the point of intersection of the solution is that part right there. Okay. Now, notice I erased it because I had to regraph it. And truthfully, I should have graphed it after I figured out the point. But again, not a big deal there. Okay. Example 4. Same thing. Try it out. All right. This one's a little bit more straightforward. When I graphed it, this one's actually a little easier to see. Sorry, let me go back to the graph fast. You can kind of see there is a separation there. So right off the bat, there's no solution based on the graph. And then if I do this, my discriminant value was -4. And I'm going to label this right here because I have thing discriminant. Sorry. That means there is no solution also at the same time. So, there's no, let me phrase that. There's no real solution. Let me clarify that. There's no real solution to these. And we're not going to actually determine complex for these particular pieces. So, anyway, so one more, last one. And again, try it, verify graphically. Here's the last one, folks. Again, 2 intersection points. My discriminant value was 8. Sorry, I didn't mean to do that. I don't know why I did that. It was 8. And then when I did this, I plugged it back in again using my linear. I got -1.82 as my y. So this is my y value here. And then when I graphed it, I verified it. Those fit. And there you have it. That's how you solve a linear quadratic system graphically and algebraically. Okay. If you can minimally at least be able to do the graphically part, where you can look at something like this, I think you'll be fine. But you definitely want to be able to know how to do this if you're trying to go forward, depending on what your path is. Anyway, all right. Y'all have a good rest of the day, and we'll see you later.